So in the last class, we discussed about what are the different reactions of the phenols, right? So we'll see about what is the importance of the alcohols and few commercial preparations of these alcohols. Okay. So important alcohols. Alcohols can be the methanol or ethanol. Mostly it is classified into either the methanol or ethanol. So methanol, as the carbon is only one, and ethanol, the carbon is two, with a functional group OH. So we call it as ethanol. So what is how do we prepare the methanol? So earlier, methanol was produced from the distillation of the wood. So that means you will heat up the wood at a very high temperature in anaerobic condition. There is an absence of air. So when you do that, you will be getting this methanol. So that's why the methanol is also called as the wood alcohol. So just remember, this is not the ethanol, methanol. Okay. So the carbon number one, which is also called as the wood alcohol, because in the ancient days, they used to prepare with the wood. So see here how it used to happen. So most methanol is prepared by the catalytic hydrogenation of carbon monoxide. That means you take the carbon monoxide, you do the hydrogenation. What is meaning of hydrogenation? Adding of hydrogen. Okay. So that is called as hydrogenation. So react with the hydrogen gas in the presence of ZNO, Cr2O3, and it should happen at a high temperature. So 300 to 400 degrees Celsius and high atmospheric pressure. So 200 to 300 atm. So that will give the methanol. Understood? So most of the methanol is prepared by the catalytic hydrogenation of carbon monoxide. So we say it is a catalytic because you are using the catalyst here, and we call it as hydrogenation because we are treating it with the hydrogen gas. So what are the properties of this methanol? So if you see the harmful effects of the methanol, methanol is a very toxic compound. So if you take the small quantities of the methanol, it will cause the blindness. And if we take the large quantity, it will cause the death. And methanol poison can also by inhalation. That means whatever the vapors of the methanol is there, if you breathe for a prolonged time, it will cause the poisonous. And even if it is exposed for a long time to the skin, it will also cause the poison. And what are the uses of methanol? So methanol is used as a reactant where you will be preparing the formaldehyde using the methanol. Apart from that, it is used as a solvent in the paint. And it is also converted into the formaldehyde by using the metal oxide catalyst. Okay, so whatever the formaldehyde that we are saying here, it will be done by metal oxide catalyst. So just remember this. So these are the uses of the methanol. So the toxicity of the methanol. So we said, if we take in a less quantity, it will cause the blindness. If we take the large quantity, it will cause the death. So methanol is a very toxic in nature. So when it enters into our body, whatever the methanol is there, it will be oxidized to formaldehyde. So the alcohol is converted into aldehyde. So it is an oxidation. We saw how the alcohol will oxidize into the aldehydes. So there's an oxidation will happen. And this formaldehyde will further convert into the carboxylic acid. So carboxylic acid is nothing but the formic acid. It will further convert into the formic acid. Formic acid is nothing but the carboxylic acid. Okay, so this will oxidize further. So just remember, it will oxidize further and turns out to be the formic acid. So methanol will oxidize into formaldehyde. The formaldehyde will further oxidize into the formic acid. So this formaldehyde and formic acid both are poisonous, and it will travel to different body parts through the blood. And it will also affect the nervous system and the retina of the eye. And it will cause the permanent blindness. If you are taking the small quantity, it only causes the damage to eye. But if you take the large quantity, it will cause the death. So it will also cause the death. Apart from the blindness, it also causes the death. Okay. So when someone consumes the ethanol, we should give ethanol to reduce the harmful effect. Okay. So just remember, If the person gets the methanol poison, what is the antidote for methanol? It is the ethanol. So just remember, ethanol acts like a antidote for the methanol. So whatever the harmful effects are there for the methanol, that will be buffered by the ethanol. It acts like the antidote. So it will reduce the harmful effects of the methanol, and it will prevent the oxidation of the methanol into aldehyde, formaldehyde, or oic acid. Okay, so see here. So whatever the methanol is there, methanol can be converted into the formaldehyde or formic acid. Both are very dangerous. So we need to prevent that. That can be done by giving the person with the ethanol. So ethanol will act like an antidote. It will prevent the methanol oxidize into the formaldehyde or formic acid. Understood?
Yes, sir.
Okay. So how do we prepare the ethanol? So that's about the methanol. So how do we prepare the ethanol? So ethanol can be made by the fermentation of the sugars. Okay. So synthesis of ethanol in the form of wine. So whatever the wine, okay, so that will happen by the fermentation of the sugars. That means you will spoil the fruits, spoil the sugars, and in absence of oxygen, you will spoil that. And some fungi or some kind of bacteria will act on this, and it will decay and it will form the ethanol. So what is ethanol? It is nothing but whatever the sugar canes are there, the spoiled ones is nothing but the ethanol. Okay. So was probably first accomplished in the field of organic synthesis. So you see here, we can take the sugars from any from wide sources. It can be the fruits, vegetables. Okay. So used in the preparation of the alcoholic beverages. Okay. So often these sugars are from the grains. So whatever the food grains are there, the wheat. Okay. So or the grapes. So from those we'll get. So it is this derivation accounts for the ethanol having the synonym called the grain alcohol. If the person prepares the ethanol from a grains like the wheat and paddy, so then mostly wheat. Okay. So then we call that alcohol as the grain alcohol. So how does this will happen? You see here. So these are the grains or different other sources where you can prepare the ethanol. So how does this will happen? Whatever the glucose is there, the C6H12O6. What is this? It can be the glucose or fructose. Both are isomers, optical isomers. So in the presence of a particular enzyme called the zymase enzyme, in presence of the oxygen. So this will be converted into the C2H5OH, and carbon dioxide will be liberated and water will be produced. So C2H5OH, C2 means eth, and OH, alcohol. So we call this as the ethanol, carbon dioxide and water. Okay, here the carbon dioxide gas will be liberated. So just remember, this is how we'll be preparing from the grains. So whatever the grains contains the glucose and fructose. This glucose and fructose in presence of zymase enzyme and the oxygen, it will convert into the ethanol and carbon dioxide and water. Okay. So that's how the ethanol is prepared. So we said either it can be done by the zymase or invertase enzyme. So where do we get these zymase and invertase enzymes? So those will come from the yeast. Okay. So just remember, whatever the enzymes that we are using, they are invertase enzymes, or it can be the zymase enzymes. So these zymase and invertase enzymes will be obtained from the yeast. So this yeast will convert the glucose. Okay. So first, whatever the invertase enzyme is there, that is comes from the bigger complex molecule. Okay. So that bigger complex molecule will break down and it will convert the glucose or fructose. This glucose or fructose in presence of the zymase enzyme, it will break down into the ethanol. So just remember, fermentation usually carried out by adding the yeast to the mixture of sugars and waters. So what does the yeast contains? It contains the enzyme, the zymase, that will promote a long series of reactions and ultimately convert the very big molecules into a simple molecules, like whatever the sucrose or maltose, all those are there. They will be break down into either the glucose or fructose. Now this glucose or fructose in presence of zymase enzyme, it will convert into the ethanol and the carbon dioxide. So just see this reaction. So whatever the macromolecule is there, C12H22O11. So with water, in presence of an enzyme called the invertase. So this will be converted into the glucose and fructose. So both are having the same formula because they are structural, formula is same, but the structures are different. Optical isomers. Okay, so glucose and fructose. Now this glucose or fructose in the presence of another enzyme called the zymase. So that will be converted into ethanol and carbon dioxide. So just remember, so whatever the complex molecules are there, they will break down into the simple sugars in the presence of the enzyme called the invertase. And these simple sugars, either the glucose or fructose, will further convert into ethanol and carbon dioxide in presence of the zymase enzyme. And where do we get this invertase and zymase enzyme? It comes from the yeast. Okay, so yeast will supply these enzymes. So just remember, so fermentation doesn't produce the beverages with an ethanol content greater than 12 to 15%. Okay, so that means whatever with the help of fermentation, we are getting only 12 to 15% concentration. But if you take the whiskey, brandy, rum, so all those mostly contains the 42% of the alcohols. But here it's only 12% is obtained. So enzymes of the yeast are deactivated at high concentration. So what happens? Why only 12 to 15%? Why can't we get more percentage? Because if the concentration is increased, whatever the enzymes of the yeast are there, they will be deactivated. Okay, they will stop conversion of the simple glucose into the ethanol. They will not convert. They will get deactivated if the concentration increases beyond 12 to 15%. Okay, to produce the beverages of higher alcohol content, that is, the highest alcohol content is 42.5%. That's in whiskey, brandy, and rum, all those. Okay, so higher alcohol content that can be obtained by the distilled. Okay, so distillation. So that means whatever the concentration is there, we'll be continuously removing it. Okay, so removing, and we are making it a concentrated one. For suppose you got this bucket got 12% of the alcohol. So what I'll do with the help of distillation, I'll remove this 12% alcohol. And whatever the leftover is there, again, it will start making to 12%. By this, whatever the alcohol that is formed, that complete alcohol, I'm removing it through the help of distillation. So all this that I removed, I obtain that into another one, which contains only that particular alcohol. So it will be having the 100%. Okay. And whatever the required percentage is there, I will do that by diluting. Okay. So just remember, to obtain the higher alcohol content, we'll be using the distill process. Just remember that much. Okay. So normally it can only obtain 12 to 15%, but in order to get more percentage, we'll be doing the distillation. So industrial preparation of ethanol. So how do we prepare in the ethanol? Okay. First, we'll be taking ethene. What is meaning of ethene? It's nothing but the double bond. Okay. Ethene. Eth. That means 2 carbon. Ene. Double bond. So CH2, double bond CH2 with water in presence of a particular acid, it will convert into CH3, CH2OH. So whatever the unsaturated compound is there in presence of the acid, it will become the saturated compound. Why? We know the acid is a proton donor. Acid is a proton donor. So it will donate the H plus. So whatever the H plus that are donated, so those will break the double bond and they will make the single bonds. So that's how ethene will turn out to be the ethanol. Okay. So whatever the world, okay, we are preparing the ethanol on this world. 5% of that is only prepared through this way. Okay. So 5% of world's ethanol prepared by this way. So this one you remember. So next one, denaturation of ethanol. What is meaning of denaturation? Sometimes we need to keep this ethanol not for using into the beverages. So what we do? Sometimes we mix the toxic and bad tasting additives so that this ethanol will not be useful for the drinking purpose. It will be useful for some other purpose. So just remember, to avoid the ethanol for the beverages, there are some other things or ingredients will be added to the ethanol so that it will be unfit for the drinking. So it will be only completely used for the other purpose, not for alcohol consumption. Okay. So what do we do that? For suppose you take the copper sulfate CuSO4, which gives the color C2H5OH plus. So here the CuSO4, it gives the color. And this compound will be giving the foul smell. So C2H5, this is our ethanol. So by mixing this copper sulfate and the foul smelling compound, okay. So here this is I think it's a pyridine. Once check, did I give you yesterday the pyridine structure? One second, guys.
So you didn't give it yesterday, but that is pyridine structure.
This is pyridine only, right?
Yes, sir.
So just remember, this is pyridine. So just remember, so for this ethanol, we are adding some coloring agent and we are adding some foul smell pyridine. Okay, so that it is not for the using for the beverages. Okay, because of this unfit for drinking. So this process we call it as the denaturation of ethanol. Okay, so why we are doing the denaturation of ethanol? To make it unfit for the human consumption, so that it will be avoided and it will be used for some other purpose. Okay, so you may ask, sir, why to add this? Why shouldn't we just simply do the ethanol? So we know people, if they found this is ethanol, they will stop using for the other purposes and they will start using for the drinking. So in order to avoid that, we make this way. Okay, so we'll try to make this way. Understood?
Yes, sir.
So see here, denaturation of alcohol, pyridine, is useful for foul smelling. It is done to make it unfit for the human consumption. So if anyone tries to drink that, because of its very ugly smell and taste, no person will dare to drink it. Otherwise, what happened? We have seen in the time of Corona, when there is a lockdown, people couldn't get the alcohol and they start drinking these spirits and sanitizers because too much of addiction to the alcohol. So we will do this way to prevent the drinking. Okay, and can be utilized for some other purpose. So reaction of phenol with chloroform in the presence of dilute sodium hydroxide finally introduce which one of the following functional group? Remember, yesterday we discussed about this. So what is the answer?
Sir, option B.
Option
D.
D. B or D? Nitya?
Sir, aldehyde group.
D. Yeah, it is correct. So what happened here? First, suppose you take the phenol. That phenol you treat with a chloroform. What is chloroform? It's nothing but methyl chloride, trichloride, CHCl3. Methyl trichloride is nothing but the chloroform. And you treat with a sodium hydroxide, dilute NaOH. And you eat this process. So finally, what happened? Yesterday I told you. Okay. So in the OH group, the H is a proton. It will donate like the proton, like H plus. And what happened? There is a breakdown of Na, and that Na will just go and jump here. And then there is again rearrangement will happen, and that will form the OH. And finally, it will give the CHO here. Okay, there are intermediate steps will be there, and finally this will be formed. Okay, so just remember, on treating the phenol with the chloroform in the presence of the sodium hydroxide, it will give the aldehyde on the ortho position. So what is this position? Ortho, meta, para. So just remember, it is OMP. So it gives on the ortho position. Tell me this. Yesterday I told you. So it involves in the two steps. Step number one is creating the electrophile, and the electrophile will attack. So what is the electrophile here? CCl2 or CCl3?
CCl2.
Nitya?
CCl2.
CCl2. Okay. So what is this reaction? Mandara, you say? What is this reaction called as? Yesterday I told you two named reactions. So what is this
Right.
reaction? Yeah. Huh? Yeah, you are correct. What is that? Yeah, it's a Reimer-Tiemann reaction. So what happens in the Reimer-Tiemann reaction? So there is a CHCl3 and there is a NaOH. So whatever the CHCl3 is there, it will break down in the presence of NaOH into the CCl3. And this CCl3 will further lose one chlorine and it will convert into the CCl2. Okay. So this one, we call it as the electrophile. So in the step number one, the creation of the electrophile. So what is the option? The option C is correct. Next one. Just now we discussed. So what is that name?
Salsaldehyde.
It is a salcyaldehyde. Okay. So there is a phenol, OH. So that phenol, when it reacts with the CHCl3, chloroform, and sodium hydroxide, NaOH, on eating, it will form the benzene with OH phenol, and on the ortho position, CHO, aldehyde. So this one we call it as salcyaldehyde. Or we can also call it as ortho hydroxybenzaldehyde. Okay. So ortho position, and this is a hydroxy, and this is a benz, and aldehyde is present. So you can also call it as ortho hydroxybenzaldehyde. Okay. So next one, Friedel-Crafts reaction. So what happens when you treat the phenol with a zinc test? I told you there's a one reaction we saw yesterday. So when you treat the phenol with a zinc test, what happens?
The OH group gets removed.
The OH group gets removed and it will turn out to be the benzene. So see here, what happens here? So when you react the phenol with the zinc test on eating, whatever the OH group is there, that OH group will be removed. and this will turn out to be the benzene. Okay, so see here, phenol is distilled with a zinc test followed by the Friedel-Crafts alkylation. Okay, so with a propyl chloride in presence of aluminum chloride, that will give the compound B. So whatever that we got now, the benzene. So this benzene is saying it will undergo the Friedel-Crafts alkylation with propyl chloride. Propyl chloride means that's a 3 carbon and there is a chloride. And in presence of aluminum chloride, it will be giving the compound B. And upon B is oxidized in the presence of air, so that will convert into the compound C. So what will be the structural formula for the C? So let's see how this will continue. First, suppose the benzene. So this benzene, what he said, it will react with the propyl chloride. So what is meaning of propyl chloride? CH3, CH2, CH2. So meth, eth, prop, 3 carbons. So prop, chloride, so chlorine. So this is called the propyl chloride, which is nothing but C3, H7Cl. So this is called the propyl chloride. And this is happening in presence of the aluminum chloride. So there is a AlCl3. So what happens now when it happens in the AlCl3? So whatever the bond present here, it will break down and that will attach here. So this reaction will happen like this. Okay. So see here. So whatever the carbon that is present here, that carbon will attach to this carbon. So whatever this is there. Okay. But it will not join at the end. Instead, it will be sitting at the secondary carbon. That means this secondary carbon will go and bind here. And what else he said? So it will be oxidized in the presence of air. So when this one is oxidized, so what happens? The secondary carbon will turn out to be what when you oxidize? So just remember, whenever you oxidize this, the secondary carbon, it will turn out to be the carboxylic acid. Okay. So just remember, this will turn out to be whatever that is there, it will convert into. So there's a C and there's a C. So let's write it as CH3, CH3. And whatever the structure is there, the COOH will come and bind here. So this is how it will turn out to be a carboxylic acid. So just remember the phenol, when you react with the phenol, when you react with the zinc test, it will produce the alkene. So that alkene, when you treat with the propyl chloride in the presence of aluminum chloride, it will undergo the Friedel-Crafts alkylation. Just remember. So whatever the thing that's happening here, we call this as the Friedel-Crafts alkylation. If you don't remember what is this Friedel-Crafts alkylation, just go and go through the previous PPTs. I've explained there. So it will happen the Friedel-Crafts alkylation. And we remember when there is a Friedel-Crafts alkylation will happen, it will involve in the formation of the carbocation. There will be hydride shift will happen, and that will result in formation of isopropyl benzene. So this is isopropyl benzene. Instead of attaching at the primary carbon, it will try to attach on the secondary carbon. So just remember this is isopropyl benzene. So this isopropyl benzene, we also call it as the cumin. I explained you all this. Just go and refer this Friedel-Crafts alkylation. You will get all this. So this isopropyl benzene, when you treat with the air, the oxidation will happen. That will result in formation of this. Okay. So this is called as the cumin hydroperoxide. If you see here, the oxygen and oxygen just attached here. Sorry, I said carboxylic acid. It's not a carboxylic acid. My bad. It's not COOH. What is COOH? C double bond OH. This is called the carboxylic acid. But if you see here, the carbon attached to oxygen, oxygen attached to another oxygen, and then hydrogen. So there is a single bonds present between the oxygen and oxygen. So we call it as the peroxide. Okay. So this is named as human hydroperoxide. Okay. So just remember, it will form the human hydroperoxide. So the answer will be option C. Understood? How we got this answer?
Yes, sir.
Mandara? Yeah. So next one, see here. So what will be the product obtained if you react the phenol with NaOH, carbon dioxide, and hydrolysis?
Option C.
C.
Option?
C.
Yeah. The option will be salicylic acid. So we saw this. So it's nothing but it will form the benzene ring OH, and this will form into C double bond OH. We saw this in the study class. Okay. So this will be the salicylic acid. And what is this reaction called? What is the named reaction?
Colby's reaction.
Yeah, this reaction is called the Colby's reaction. So next one. What is the answer for this? So phenol undergoes Colby's reaction, ethanol doesn't. Is it correct? So just remember, only the phenol will undergo Colby's reaction, not the ethanol. Okay. So we need the benzene with OH, not the simple aliphatic compound. So this is also correct. Phenoxide ion is more basic than ethoxide ion. Nope. Phenoxide ion is more basic than the ethoxide ion. So just this answer is wrong. Okay. Just remember, phenoxide ion will be less basic than the ethoxide ion. Do you remember what's the reason for this? If you remember, initially, like in the previous classes, we have seen the comparison between the phenol and alcohol. So when we do that comparison, I told you that phenol is more acidic than the ethanol, if you remember or not. So we have studied, we have seen the comparison between the phenol and alcohol. So when we do that, I told you that phenols are more acidic than the alcohols. And here the ethanol is an alcohol. And phenol is more acidic. So obviously, phenoxide ion is more basic. No, it will be less basic. Ethoxide ion will be more basic because phenol is more acidic. That means phenol will be less basic. Understood? So from this, what will be the answer?
Option
The
C.
assertion is correct and the reason is wrong. So just remember this. Okay. So write down this statement as well. Phenoxide ion is less basic than the ethoxide ion. Phenol is more acidic than the alcohol. So from this, I can draw the inference. Phenoxide ion is less basic than ethoxide ion. You can draw the inference from this statement. Okay. So from that, you can say this statement is wrong and the statement one is correct. So assertion is correct, reason is wrong. So next one, methanol is industrially prepared by, just now we saw. How do we do the methanol by industrially? Just now I told you the first few slides. Come on, what is the answer? So carbon monoxide, when, huh?
Is it D?
Yeah, the option is D. So carbon monoxide, when you treat with the hydrogen gas in the presence of ZNO and Cr2O3 at high temperature, 300 to 400 degrees Celsius and 200 to 300 atmospheric pressure. So this will convert into methanol, CH3OH. So the answer will be D. Reduction of carbon monoxide using the hydrogen and zinc oxide and chromium oxide, Cr2O3. So next one, what is the answer? Which reaction is this? Okay, I didn't explain you this reaction. So you can eliminate these options. So the option will be either the B or C. So what is this reaction? Friedel-Crafts or Reimer-Thymann? Where you form the benzaldehyde, ortho-hydroxybenzaldehyde, which is also called as salsaldehyde.
So
Which one, Mandara?
B. Reimer-Thymann reaction.
Yeah, the answer is B. So what happens? The phenol treated with the chloroform in the presence of potassium hydroxide. So this will see here potassium hydroxide, or you can take also NaOH. Okay, so it's nothing but both are same. So anyway, we will be taking some one basic group. So here potassium hydroxide is the base I have taken, and this will give the OH with CHO. So just remember, it can be the KOH or NaOH. So tell me, what is the answer for this? I told you how the H will break down and it will turn out to be O minus. Just forget about CS3. Just take it, look it like a only the phenol. And how does this will happen?
So will it be option C?
Yeah, it's the option C. So just remember this one in presence of the aqueous NaOH and CHCl3, it will give ONA. Actually, it will give this way. Before, actually, there will be rearrangement will happen. Before rearrangement, it will be like this. So this will give the benzene ring with O minus Na plus, and there is CHCl2. That will further, when you treat with NaOH, this will convert into the CHO and there will be CH3. This upon aqueous HCl, this will turn out to be this. So what is the reagents here? NaOH and CHCl3. So the option is C. Next one. Which one will be the major product and which one will be the minor product? And I told you, we'll be doing the distillation. At which point, which one will be obtained? See, this question is depend on the previous question. Okay. So from this question, so which one will be yielded more? So what happened? Finally the product which is formed is benzaldehyde. Okay. Salsaldehyde, that is the benzene ring with OH in presence of CHCl3, NaOH, and proton. So it will happen in two steps, 1 and 2. And this will finally turn out to be the benzene ring with OH and CHO. So one is this form, the other one is the benzene ring with CHO on para position. So one is on the ortho position, the other one is in the para position. So which one will be the major product, ortho or para?
So,
So this will be the major product and this will be the minor product. And remember, what is this reaction we call it as? We call this reaction as Reimer-Thyman reaction. So in the Reimer-Thyman reaction, we'll be getting the ortho salsaldehyde and para salsaldehyde. Okay. So one is the P, the other one is Q. If you see here, the P product is more than the Q product. So which one will be the P here? This one will be the P product. And this one will be the Q product. Okay. I told you why. Why the P product will be more and why the Q product will be less. Because there will be intramolecular hydrogen bonding that happens in the case of the orthosalsaldehyde. Okay. So just remember. So you will be getting the two products. One is orthosalsaldehyde and you will be getting the para salsaldehyde. Okay. So in these two products, the ortho one, it will be having intramolecular hydrogen bonding. So because of this intramolecular hydrogen bonding, the boiling point for the P is less than the Q. Okay. So the boiling point of ortho is less than para. Okay. So what happens with the molecular? What happens with the melting point? So the melting point also will be the same. Okay. So just remember, so due to the intramolecular hydrogen bonding, so orthosalcialdehyde, okay, melting point and the solubility will be less compared to the para one. So not only just boiling point of ortho, but even the melting point as well as the solubility in water. So all these will decrease. You can also consider the acid strength as well. So all these will decreases. Okay. So boiling point of ortho is less than para. Melting point of the ortho is less than para. Solubility in water is less than the para. Acid strength is also less than the para. So why? Because of the intramolecular hydrogen bonding. I've shown you what is this intra and intermolecular bonding, hydrogen bondings. I've shown you the pictures in the previous PPTs. So once just go there and refer it. So what will be the answer here? What is P here? The P is nothing but the ortho. And what is Q? It is nothing but the para. So ortho is having less than the para for the water solubility. So it is correct. But if you see all the other things, it is not matching. Even if you see here, this should be P less than Q. Otherwise, this would also be correct. But here it's given Q is less than P. So only the one which is matches here is this one. So just remember, so orthosalsaldehyde, it will be the major product and this will be the minor product. Okay. But this orthosalsaldehyde, it is having the intramolecular hydrogen bonding. Due to that, the boiling point of ortho will be decreases, melting point decreases, solubility decreases, acid strength decreases. So remember. Understood? Any doubts?
Yes, sir. No, sir.
So next one. PHMGBr, when treated with X, it gives the phenol. What is the X here? So just remember, so in this, the X should be the acidic hydrogen. Okay. So X should be the acidic hydrogen. So which one is having here? It's only this one. So in this condition, the OH, the H can break down here and it can liberate the H. So option B will be the correct answer. So which among the following compounds is the most acidic in nature? So just remember, water will be the more acidic than any alcohols, except one alcohol, that is methanol. So just remember this one. So note, water more acidic than all alcohols, except one alcohol. Okay, except one alcohol, that is methanol, which is CH3OH. So if you see, this is alcohol, this is alcohol, this is water, and this is methanol. So if I see the C and D, these are not much acidic than the water, but methanol is more acidic than the water. So my option will be the B. Understood why the option is B?
Yes.
So next
Yes,
one.
sir.
So when vapor of an alcohol is passed over copper at 300 degrees Celsius, the product is isobutane. Alcohol in this reaction will be. So what will be the alcohol here? Isobutene. What is meaning
Sir,
of
will be
iso?
closely.
What is meaning of iso?
There are three carbons attached to
Yeah,
the one.
there are 3 carbons attached. Okay, if you see here, only this one is able to make the iso. But if you see here, my alcohol can attach here. I mean, my alkene can form here, can form here, can form here. If other than this place, if the double bond forms any other place, it will not be iso. So this will not be my option. This will not be my option. This will not be my option. So the only option will be D, because this is the only case where even if I dehydrate this, if I remove the OH, the only case they can make is either here or either here or either here. So that will make the iso alkene. Okay. So that means the iso double bond. So just remember. So CH3, C, CH3, CH3, OH. So in the presence of copper, 300 degrees Celsius. So what happens here? Let me elaborate this structure. This is my main carbon, isocarbon. Let me put it star and OH. So what happens here? Whatever the hydrogen that is there, it will try to make the bond here. And so that it will form the double bond here. So when it able to form the double bond here, it can leave this one. Okay. So by that, the OH and hydrogen can leave and it will make the double bond here. So just remember, so there will be hydrogen will liberate and whatever the electrons are there, those electrons will try to make the double bond here. And here the OH will leave, the hydrogen will leave. So both will leave like a water molecule. And that will result in formation of C double bond CH2, CH3, CH3. So which is nothing but the isobutene. Understood?
Yes, sir.
One second, guys. My charging is over. Okay, we'll complete it. Only few slides left. So which is not likely product forward when the following alcohol is treated with a concentrated sulfuric acid. So what happens when you treat with a concentrated sulfuric acid? It will donate the protons. Yes or no? So the protons will be, so just remember how this reaction will happen. So whenever, so the compound is present like this. So when I treat with the concentrated H2SO4, it can form isomers where at different points the hydrogen can be added. So I'll just draw the same structures. So one hydrogen I am taking here. Okay, so whatever the carbon that is present here, it will be having three hydrogens, right? So if you see here, the carbon can contain three hydrogens like this, CH3. So one hydrogen, I'm just elaborating the structure here. Okay, so that we can refer. And whatever the OH is there, because of this H plus addition, this will turn out to be the OH2. Okay, so this hydrogen will break the bond, and whatever the electrons are there, it will try to make the double bond here in this condition. And in this condition, the same. So whatever the electrons are there, it will form, the proton will form the OH2, and whatever the hydrogen that is present here, it will break the bond, and whatever the electrons are there, that will try to make the double bond here. So upon eating, so all the double bonds, so the water molecules will be removed. And this will form the double bond here. And here also. So understood what happened here? H2SO4. H2SO4 is nothing but the acid. Acid is nothing but a proton donor. So when you donate the proton, whatever the OH is there, the OH will take the proton here, and that will turn out to be the OH2. But this is a very weak group, so it will try to, this will be very strong leaving group. This is a very strong leaving group. So this will try to leave. When it will try to leave, there will be double bond will be formed here because the hydrogen also will leave here. So that's how the hydrogen double bond is formed here. Or the double bond can be formed here. So you will be getting two different kinds of structures. Okay. So based on that, you should be able to choose the option. So next one. So there is a compound A. You do the protonation and you do the eating, that is turned out to be this product. First, suppose we'll see how this will happen. First, suppose if you do the protonation, okay. First, suppose let's take, this is the A is this structure. Okay. So let's say A is this structure. So when you do the H plus, what happened? So this H plus will be adding here. So this will be turning into OH2. So this will leave here. And whatever the carbon that is present here, it is also having hydrogen here. So that hydrogen will be liberated. So suppose the hydrogen is present like this, that will be liberated and making the double bond here. Okay. So that will be able to form the bonding like this. If you see the B, so what happened in this case? here the water molecule will be formed here. So this will be liberated. And whatever this carbon is having hydrogen. So that hydrogen will make the double bond here. So in this condition, the bond will just happen like this. Next one, this is the condition where the protonation will happen and the hydrogen will be attached here. So this will be leaving. And let's say the hydrogen here, it will be broken and it will try to make the double bond here. So this will be turn out to be like this. So what is this? So does the hydride shift can be happen in all the three, right? So it happened here, here, as well as here. So the option will be the D. So if you see all these structures are same. So all of these. And the last one, NaBH4. So what is NaBH4? We studied. NaBH4 is nothing but a mild reducing agent. So what happens with the mild reducing agent? So if you do the NaBH4, whatever, okay, that is present here, it will be reduced to the aldehydes. Okay, so what is this group? It's nothing but the C double bond O, and that is attached to the CS3. Okay, so now this one, this is just a C double bond O carbonyl group that is having CS3. Okay, so when you do the reducing, so whatever this oxygen is there, double bond is there, that double bond will break and this will hydrogen will attach to this O. So that will turn out to be like this. So whatever the carbon is there, that having the double bond with the oxygen, so one bond will be broken and instead of one hydrogen will just come and attach here. So it is formed into which alcohol? The primary alcohol. As the OH is attached to single carbon, so it's a primary alcohol. What is this group called? So if you see here, how is it is there? So it is like this, C double bond O. And carbon can also make a one hydrogen. So this is like a CHO. So CHO is nothing but the aldehyde. So the aldehyde is converted into the primary alcohol when there is a mild reducing agent. So just remember, this is a aldehyde group and this is a primary alcohol. So when you use the mild reducing agent, aldehydes will convert into the primary alcohols. Understood? Any doubts?
No, sir.
Okay, then we'll stop here. Bye. Good evening. Happy Diwali. Advance happy.